Cool. So, so Sentinel is, we can call it as a next generation SIEM. SIEM is stands for security information and event management, right? So where in security we have a big problem like collection of the data analysis, and helping to detect threats. That is a like ever problem like if you see the past where the traditional databases whatever we have will not support our security information and events. So that's the reason we need a separate technology and techniques to store the data and to detect the threats. That's the reason we have a concept called SIEM, Security Information and Event Management, and we have a few products into that. For example, in the past, like the leading product was ArcSight from HP, and lately Splunk took the challenge like to build the next generation SIEM, and they have succeeded, and they are like competing from the past. And very recently, from last 2 years, I think from the public release, Microsoft Sentinel, just finished 2 years. So it came to the market. So it's occupied by Splunk and HP ArcSight, and there are few products from, for example, you have Nitro and IBM QRadar also we have from SIEM. So into that market, so it's very challenging to enter any new player. So Microsoft took that as a challenge, and they built the SIEM. And while building the SIEM, they started calling itself as next generation SIEM, because all the traditional SIEMs, if you consider ArcSight, QRadar, or Nitro, they have its own challenges, where it was not supporting much into the cloud workloads, and they are not to the scale up to the customer's requirement. So that's the challenge where Microsoft took that, and they built the SIEM product calling next generation SIEM. And earlier it was being called as Azure Sentinel. Recently they have renamed it as Microsoft Sentinel. So going forward, sometimes I may refer Azure Sentinel, just consider it as a Microsoft Sentinel.
Yeah, sure.
So just to touch base, like what exactly Microsoft Sentinel does it, right? Initially, when Microsoft Sentinel born, we called it as a cloud native SIEM, which means it built on the cloud for the cloud workload. So it's the first SIEM which built directly on the cloud. For example, if you consider the other SIEMs like Splunk, it was built for on-premise, and it built as an on-premise installation, and it moved to the cloud now. But the differentiation with Microsoft Sentinel, it's born in the cloud itself, and initially they are supporting only cloud workloads, and then they had to support on-premise workloads, because all the customers or all the people who are using are not fully into the cloud. So it's a hard requirement, like any SIEM should support on-premise workloads as well. So that's the reason Microsoft Sentinel also started supporting on-premise workloads. Now it supports both cloud workloads as well as on-premise workloads. So it's like a hybrid. So like any other SIEM, like we have four main things any SIEM does. A SIEM, to be called it as a SIEM to be used for security events, we should have robust mechanism to collect the data, and we should be able to detect the threats, and you should give some mechanism to investigate and respond on the threats. So this is overall like any SIEM should support to be called as SIEM. So coming to specific to the Microsoft Sentinel, so So Microsoft Sentinel does something more than just these 4 things. So when Microsoft Sentinel born, it came up with the terms SOAR. SOAR was the term which is coined by in the earlier itself, where to solve the challenging of auto remediations. For example, when you see security threat or security security rule fired, let's say you have a firewall and you have detected that there is a vulnerable port opened. And earlier the challenge was like, when you get the alert, you had to go to firewall settings and you had to close that port. But what SOAR does is, if you have SOAR capability, can we close that port automatically whenever it detects it without manual intervention, so that you can save a lot of time and a lot of I would say a lot of money in terms of saving that the money we lose because of open port.
So
That is
that can be done with the help of playbooks only, right? I mean, inside Sentinel.
exactly. Bharat. So in Sentinel, the SOAR, whenever we call it as security orchestration, automation remediations, right? It's nothing but the playbooks.
Yeah, got it.
So that's the additional thing which we have in Microsoft Sentinel. It does through playbooks. And coming to the collection part, right? So like we have many built-in connectors to helps connect to the data, and also there is a flexible way you can build your own connectors, or you can pipe your own data if the existing connectors are out of the box connectors doesn't support. So that is the collection process. And coming to the detection, there is a robust detection mechanism is available out of the box in Sentinel, where it supports a KQL based technique, which is like unlike the other sims where you have to define your own rules. But here the additional advantage is you have a free form of query language, where you can write anything. I would say it's similar to you write stored procedures in SQL, or the script in the shell. If you have background on that, similar to that, you can write a complete program where it will helps to detect the threats
Yeah.
which is required.
We actually are in my project. I mean, the integration part was already completed right now. I mean, before we came into the project, they split it as 2 projects, the same project, and the integration portion was completed. Actually, they hired all of us for the operations part.
Okay.
Hello. Yeah. So they are expecting the KQL from everybody. Actually, but I don't have any knowledge on any experience on KQL. I know SQL, but I don't have any experience with the KQL queries and all. So right now in this course, are we using the KQL commands? I mean, the basics at least, which is related to Sentinel, not for the complete course.
Okay. Yeah, I think once if I finish that, we can discuss the expectations, Bharat,
Sure.
so that it will be clear, because I'll run through that because Mish is asking to give a demo. So in general, I'm going through that, not to the specific requirements, but after that, we'll discuss that requirements.
Sure.
So yeah, that is the detection part where, like you said, we use KQL. After that, investigation comes into picture. Like when you have already KQL defined and you detect the threats, right? And once the suspicious activity came up onto your screen, you need to investigate it. So Sentinel supports uh, built-in tools to support your investigation. And coming to the response stage, when do you need to respond? So, we have the playbooks we can define, which helps to rapidly take the action. Not like manually you will take some time and you will wait for approvals. But if you have playbook defined, it will take action in and there. So that is the advantage with the response tools which we have in Sentinel. Moving forward to the data collection part. So the data collection part, if you see here, we have a built-in tools to collect the data from multiple sources. Like it can be on-prem or it can be cloud. In the cloud, like we see, we can get the data from Office 365 or any of the IaaS VMs or PaaS VMs. Are already we have the security alerts being detected by Office ATP, Azure Defender, anything, right? You can ingest them directly. And also it can connect to other clouds like AWS. We can get the data. And of course, as I mentioned, it's a hybrid. We can get the data from on-premise things. Like Palo Alto firewalls, Checkpoint firewalls, Cisco devices, Umbrella, like things, or any other syslog mechanism like we have in Linux, or all the data through Windows agent. We can collect the data using for the on-premise workloads. So this coming to the detection part. So we have built-in detections already. We have more than 100 plus built-in analytic rules where it come up with whenever you install a solution or install a package, you will have built-in detections come up. So you can use that very well if it supports for your environment. Otherwise, you can customize those for your requirement, and you can define from the scratch as well using KQL. So mainly this KQL or the building of the detection, it's supposed to correlate from the multiple tables, multiple sources. And also this will support to call a playbook. So when you define any detection or analytic rule, you have the flexibility to call the playbook. And coming to the automation part, we have security automation and orchestration platform, which is SOAR. And in terms of Sentinel, we call it as playbooks. So you have the logic apps, which is a separate service from Azure itself. And Microsoft Sentinel is tightly integrated with logic apps. So don't get confused with the logic app service and playbooks. Playbooks are nothing but logic apps. So this will help to get the flow for your alert. For example, when you see any Sentinel alert triggered, and you can post a message over the Teams, you can send a message mail, or you can block an IP in your Active Directory, or you can block your port or IP in your firewall. So these are the things you can do in the automation. So mostly we use playbooks as part of automation. Mostly these are used for incident management. For example, whenever you have an incident, you can open a ticket in ServiceNow or Jira, for example, automatically. You don't need to wait for anyone, or you can enrich the existing alert very well. For example, whenever you have an alert, you can, for example, you just have IP information in your alert, and you don't know what is the location of the IP address. So very well, you can enrich the data by looking up geo data, and you can get that. When an analyst investigate that, he'll have the full information for that. And remediation part, like I said, you can block any IP user access or isolate a machine. That's the main purpose we use it on the playbook. And coming to investigation, we have a robust tools to support investigation. So where it helps to dig down for any incident come up, you can navigate to the incident, and you can see what are the entities participated in the event, from which IP this alert came up, what is the host name, and what are the connected sources for the host name again. And suppose if a user is came up as a victim, and then we can see that particular user where all he's logged in, or what are the actions he done. You can do anything as part of investigation. see now. Let me know if you can see.
Yes, yes.
Cool. So if you see the Azure portal, I think you are familiar with the Azure portal already, right?
Actually, we haven't got our access and all till date. I mean, just we are waiting for the access that has to be granted from our client. And I don't have any Azure experience as well previously. I am from AWS background actually.
Okay.
Uh,
So we have a to navigate to log into a Azure portal. We have a URL portal.azure.com. So once if you hit that, it will ask you for credentials, username and password, where mostly you have your corporate account linked to your Azure portal as well. You might need to use the same. Once if you log in, and you can see the home screen like this. So mostly this may vary based on the configuration at the portal side. So you have multiple services like you might have seen in AWS as well. So you have all the services, or you can go to the individual services like app service, virtual machine, SQL service, similar things. So we are interested in Microsoft Sentinel. We can search for Microsoft Sentinel. Once if you search for it, it will ask you to open Microsoft Sentinel. Since I already configured Microsoft Sentinel, this is my Microsoft Sentinel screen. So if you see here as a home screen, you can see how many events are ingested in the last 24 hours, whatever I choose, how many alerts are fired, and out of alerts, how many incidents are there. This is very fundamental screen, basic screen, right? This is the home screen of Azure Sentinel. Here at the below that, you can see the alert trend, the event trend over the time. And also you can see the incidents like what are the recent incidents are there, and then what is the severity of it. Is it high, low, medium? And potentially wherever the IP address or the geolocation point out, you can see in the old map like where all my alerts are coming up. Okay. Coming to the next thing here, like I said, you have multiple options like analytics, where you can define analytic rules using KQL, and the data connectors you can see under configurations, right? Bharat, are you following? I am showing under configuration.
yes, yes, yes.
Okay. So under configuration, you have data connectors, analytics, watch list, and you have automation, which is nothing but the playbooks. So these are the multiple configuration items where we can define it. Mostly these are the items which we have discussed. So if I click on the data connectors, let's say, so I have built-in connectors, 120 data connectors already there. And if you have used any of those connectors and you connected the data, it will show right to it as a connected kind of thing. So these are the data connectors which it will show. So for example, if you need to connect the data to the Palo Alto Prisma, right, let's say.
So for Windows as well, we have a separate connector. No, I mean, in ArcSight and all, we'll have a Windows Unified Native Collector, Unified Collector or Native Collector state. Like that, we'll have any connector, specific connector for Windows in ArcSight.
Okay, so here for Windows machines or the on-prem mechanism is slightly different. So it's not the same mechanism as what it does in Splunk or ArcSight. It's slightly different, but the concept is same. Where you have an agent, where it will help to forward the data. Where
But it's an agent-based mechanism. So we are going to provide the agent, and on endpoints, they need to install the agent.
Yes, correct. You can install on each and every endpoint, or if you have other mechanism to forward. For example, Linux machines has syslog to forward, right?
Yeah,
Already built in. So you can very well configure syslog to configure to the central syslog server, and you can configure this. We call it as Azure Monitoring Agent (AMA). So you can have this configured only on the central syslog server. So where it will forward the data. So you just need something as an intermediary thing which can forward.
got it. And one more, Dr. Ovi. I mean, if for example, if I have some 50 endpoint devices of Windows, and we provided the Windows agent to all the 50 devices, and how can we monitor? I mean, in case of if any device is not sending the logs to our Sentinel, how can we identify that?
Okay. So that is so if you have baseline, we call it as baseline. Bharat, baseline is nothing but what you are aware of. So you are aware of like my machines are 150.
Huh.
So you can very well configure a rule in KQL itself to monitor traffic for every 5 minutes. Suppose you're supposed to receive for every 5 minutes, right?
Heartbeat.
And you have the events are flowing to Sentinel. So you can write a KQL. So the point here is the analytic rules. You can use not just detect threats. It also used to detect the monitoring areas. The whatever the scenarios you want to monitor, we use the same.
Okay.
So you can very well go to the log and you can query like what are all the machines which has given me data in the last 24 hours, let's say, and you found out only 149 machines has given you access and given you the data. So we can alert that in and there, like hey, there is one machine which we are missing, so that you can go and take it.
Yeah, I guess, I mean, my query is, I mean, it's wrong or right, I'm not sure. But for Windows, in case of any Windows devices, we can't identify with the help of connector, right? In case connector is active or not. There is a no connector concept for the Windows devices, right? Especially.
Yes. That's what I mean. So it's not a connector based. You don't. So if it is a connector based, very well you can help, right? Whether this connector is, so if you see, for example, if I come here, so
Yes.
if there is anything which is not reporting, it will show status as not connected.
Yes, exactly.
So since it's not a connector based, you have to define a KQL query.
Okay. Got it.
Where you go to the KQL query, and in KQL query, you have the data coming up from multiple sources, right? Which is a host name. You can baseline on the host name or IP, wherever you are confident on. So
Got
you
it.
can query what are
Customize
my
the dashboard we need to create for that.
Yes. You can create a dashboard, or you can create a rule. That rule will send an alert. It's up to you.
Got it.
Okay, that is the data connector part, and similar to that, we have built-in analytic rules, and we have multiple analytic rules. As I said, like we have, I think, 120 plus built-in analytic rules where you can use it if it supports, or else you can define your own rule as well. Let's see. I have multiple rules defined. Let's see if this. Okay, let me try to edit one of the rule. I'll show you how it looks like. So this is a KQL, what I'm talking about. So it can be a 2-line, 3-line, or it can be 100 lines. It varies, depends on how complex your detection logic looks like.
Got it.
So for example, if you see, I'll touch base, like since you said you don't know you don't know the things in KQL, I'll just roughly walk you through. Don't bother, like if it like going out of your mind. So it is like a table where my logs are resides. And so let's say I'm querying sign-in logs, and I'm interested only on event ID 50057, and the result description is this, and I'm summarizing it. So once so my intention is to identify as a detection name says that my intention is to identify if there is any logins are happening from any IPs which on disabled accounts, let's say. So
Okay.
I know that there are few accounts which are disabled in the past, and if somebody is trying to query for that, or somebody trying to log into those accounts.
Okay.
So even though it is a disabled account, the mechanism we have, right? Even our operating systems captures the failed logins also.
Yes.
So that we can use that. So it will come into sign-in logs, right? So we can use that data, and you can very well see that if the event description says that this account is disabled by administrator, and you can see sign-in logs are expecting. And for the same thing, and you can see if you next part of that query, I'm just joining with again sign-in logs to see if there is any successful login in the past, successful attempts, so that I know that it's recently disabled and people are trying for it, so that to crack something. So it is very dangerous, right? So that is my logic. So I have defined that rule. This is my KQL logic. So the first part is something you have to give name, and ID will be random, and you give the description for that rule, and you have to define your KQL query. And once if you define KQL query, you need to identify entities in your query. So entities, when I say as entities, means which has some relationship to the primary objects. For example, IP, user, or a host. These are the primary objects where are the victims. It can be on security threat, right? So these we call it as entities. So we have multiple built-in entities within Microsoft Sentinel. You see here, account or Azure resource or DNS or file hash or a malware or a process name or URL. These are the built-in rules. You have to map your data to one of the built-in entities, so that your investigation will be smoother, but it's not guarantee. I mean, it's an optional. You don't require to map it also if you really don't want or don't have that. And you need to define the schedule, like what is the time you want to run this query for every 5 minutes, and what is the lookup data you need to. Let's say I need to run for last 5 minutes, and I need to every 5 minutes I need to query the data from last 30 minutes for this logic. And you define this is common in any other sim, right? If result is greater than 0, you go ahead. And then you have few settings. Either you need to enable incident for this alert, or disable it. And also alert grouping. You can group alerts if you feel like there is a considerable things, like you can group together and investigate together. You can group it very well.
Similar kind of alerts.
Similar kind. And yes, and you have automation, automated response, the playbooks which you are talking about. And this is where you have to define playbooks in advance, and here you have to select it. For example, I have a playbook defined. I can use this to alert it to run this. Once if this alert comes, this playbook will be executed automatically, and it will help to remediate or to enrich whatever the playbook does it. And then you just save it. This is how the alert looks like. So once if we have alert, and based on your configuration, it can fire alert and incident both, or it can be just an alert, because while you are configuring, you have a choice whether you want to trigger an incident as well. So once if you have incident trigger, you have to navigate to incident tab under threat management. So I can see, let's say I have 3 incidents already flagged in my environment in the past 24 hours, right? So for example, if you consider the incident which we just configured, right? Sign in from the IPs that Distributed. Okay. So this is the incident. On the right, just focus on the right hand side. You can see details, right? This is an unassigned incident. You can assign very well to anyone. And the other one is status. Where you can keep it as closed, active, or something, and then severity is medium. So this is it will show how many alerts are part of events are part of this incident, and how many alerts are grouping to this incident, and what are the entities. This is, for example, this IP 175.45.176.99. This is that, and then you can see tactics. These are all like based on our configuration in Analytica. So you can very well click on full details, or you can click on actions, and you can navigate to investigation tab like we have seen earlier in the presentation, right? It will show up the investigation tab, and then you can see like what are the connected entities here.
Yeah, in case of any multiple geolocation access and all, we can identify whether the user is from the same location or from the different location as well, right?
Yeah, that is the investigation tab does that. So you can very well dig down and see what exactly going on, or else you can see investigation full details also. Now this screen will help you to see what are the alerts are part of it, what is the timeline of it. For example, on December 16th, 9:59, the attack started and it ended at 10:24 p.m. So this is how this attack happened. You can see very well that, and you can see alerts which are part of that, and you can bookmark entities. You can comment anything, like if you store some notes to it. Okay, I have investigated and found it, and you can comment it, and it will store back to Sentinel. So this is how Sentinel investigation and incidents look like. So we have covered alerts, data connectors very well. So yeah, this is a workflow, how it looks like. So once, for example, if you have playbooks defined, you can call those playbooks and look for the remediations automatically.
Yeah, and even if you have multiple alerts, right? For example, in case of any from a same IP, if we are getting multiple number of requests that we know that it is a false positive, in that cases we can automate with the help of playbooks, right?
You want to close it automatically if you know.
Yeah, close it automatically.
Yeah, very well you can do that. Basically, you have to close this particular incident, right?
Yeah, true.
Status you can change it. Yeah, you can change.
That's what right now we are facing that scenario, so that is why.
Yeah, you can change the status of any incident through playbooks.
Yeah, got it. And EFI suite.
Mike, you mean Azure Defender?
Yeah. I mean,
I know Azure Defender, but I don't know what is EFI suite.
I mean, actually, Microsoft Endpoint Defender, and MCAS, Microsoft Cloud App Support.
Cloud App Support, MCAS.
Yeah, MCAS.
Okay.